Which of the following could represent the graph below? So we have a sinusoidal function, obviously, and we have all of these graphs where there's similarities amongst all of them. Like, for example, for all of them, the amplitude is 2. Now, before we tarry any further, let's compare this to what a sinusoidal function looks like. Okay, you have a times either sine or cosine, so sine, cos, of b of x minus c, close it, plus d. A is the amplitude, amplitude. B is the frequency. Now the frequency is 2 pi over the period, or if it helps, the period is 2 pi over the frequency. Let's see if we have to deal with that. We'll wait a minute until we get there. C stands for the horizontal shift, also known as the phase shift. Now, it's opposite of what we're used to, okay? Where if this was something like x minus 3, you actually move to the right 3. It's a positive horizontal shift. D is your midline, also known as your vertical shift. Okay, now when I look at a thing like this, if we're given the graph and we're being asked to figure out multiple choice which is which, to me the easiest thing to do is figure out what the midline is. The midline is exactly what it sounds like. It's a line that cuts our graph in half. So it's a line that cuts our graph in half. So here, the midline, the D, is going to be y equals 1, or in this case, we'll just say 1. So we know that whatever we have is going to be blah, 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 plus 1, which eliminates u and eliminates u. Now, what I'm left with are two sine functions with an amplitude of 2. So we could see that the amplitude is 2 because it goes up 2 or down 2 from the midline, however you want to view it. We have a half for our frequency. Okay, so there's no use in us calculating that. That's not going to help us. And the only difference that I see here is that we have a 2 multiplied here. So that's different, and that shouldn't be there. We shouldn't have a 2 in front of x. So I'm going to kind of wait until the end to deal with that to see if that's something I really need to deal with. So I'm going to look at this and see if everything checks out. Amplitude of 2 checks out. Okay, we have the same 1/2, but just because that's a 2, maybe I should figure this out. If the frequency is 2 pi over the period, it's always easier for me to find out what the period is than to find out what the frequency is. So the period is 2 pi over the frequency. So the period is 2 pi over 1/2 according to this equation. So you multiply the top and the bottom by 2 to get rid of that 1/2 on the bottom, see it goes away, and you have a period of 4 pi. So in order for me to find the period, what I like to do is either take the tippy top or the very bottom and to find the distance, and that distance is going to be negative 2 pi to 2 pi, 4 pi. Now, in order for this to work out, we would have to factor out a 2, which means bring out a 2, which changes that number. So B is not going to be my answer. Okay, but just to continue the problem, just to make sure we all feel comfortable, minus pi means we actually shift a positive pi, which means we take a sine function and we move it to the right pi. Okay, sine is supposed to start and look like this. Go that way. So if the midline is 1, and if I were supposed to start here and I move right pi and actually start here, I'm good. So that checks out. Okay, that checks out. And of course, last but not least, we started out by using the midline to eliminate these two. Midline is 1, we're good. So my answer is D. So I scribbled everywhere. But the idea is, you start with the midline, sine or cosine might change the vertical or horizontal shift rather. That 2 there threw everything off, but if I factored out the 2, that changes the frequency, but the frequency is right. Just a lot to see here, a lot to do with, but we did it, and I hope this helps.